Hello FTC CADers. Welcome to April 16th, and today we're going to do a bit of a deep dive into some custom fabrication when we're talking about our drivetrain project. Now, before we go too much further, in the course of this session, I'm going to show my colors as an FRC coach. And part of the reason that I love FIRST, really, FTC, FRC, those levels especially, is the ability to custom fabricate parts. I mean, we started this with our very first challenge here around 3D printing parts and creating things from scratch. It's something that other robotics competitions don't necessarily let you do, and it's something that FIRST absolutely encourages, and that at least in my lab I absolutely encourage, and it makes your robots better when you can sometimes make things from scratch. Now, I'm going to show you what we're going to do today, because today the real challenge is to create a drive rail, and I'll explain what that is in a second. And in our lab we have access to a laser cutter, but this same session could help you with laser cutting. This could help you if you had the access to a CNC router, even a manual mill. Those are things that could be used to do all sorts of things and create these drive rails out of aluminum, out of polycarbonate. In our case, we use plywood, and a laser will go through the plywood like it's not even there, and it's actually quite a strong material for what we're doing in FTC. And it's also something that's relatively inexpensive. If you screw a plate up, which we have before, you don't feel so bad about it, and there's nothing wrong with that. And yeah, let's get started. So now, before we start, I've actually set up a file, and I've named it the Blurg, because at Mandela we actually created a robot this year called the Blurg, and I want to give a little bit of history on that, because there's a bit of a story there. We were actually floating around the internet partway through the season, and we found this absolutely wonderful CAD file from 7604 from Oregon. And these guys are amazing, and their gracious professionalism shows through. They've actually published their CAD files, and they actually published the AutoCAD, or sorry, the Fusion 360 link, much like we showed you in the last video, to actually make sure that their part files were out there. We watched this robot come together over the course of a season, which, thank you 7604, was absolutely incredible. Now, the thing that I want to look at specifically, because this is what we're going to look at here, is this section right here. This is what I'd call the drive rail. It's where we've got our main piece with our wheels, in this case mechanisms, as well. We've got, you can see there's a color sensor here, but we've actually got some supporting pieces, and we've got a way of attaching it to different parts of the robot. Some custom fabricated, I'm assuming 3D printed parts in here, as well as your primary motors. Now you'll notice that this particular rail is actually driven from two sprockets. In this case it looks like an 80 tooth to a 40 tooth sprocket, drives the mechanisms. And the nice thing is, as we talked about before, if you want to use the explode menu, you can actually open this up and you can actually see how each individual subsystem of this actually goes together. Now, these guys have actually used, I'm going to zoom back in here using my home button, these guys have actually used a really interesting setup, I'm assuming based on what they have in their lab, which is some channel from Tetrix and some pre-built spacers. I'm actually going to go a little bit off the board, and I'm going to use a bit of a different part to space our drive rails out. I'm going to use an FRC here, a traditionally FRC part. So let's hop back to Fusion and see what I've got already. Now, I've done some pre-work on this. I'm going to warn you, you're not going to be able to finish this whole thing in the same amount of time as this video, because there's a few things I've put together. Okay, the first of which is a pre-built Mecanum drive wheel. And this one is actually a Studica Mecanum. They're fantastic Mecanums. I haven't used their actual included mounting system, because what I want to do right now is actually run an axle all the way through the thing. I want my Mecanum supported on both sides for this particular bot, because I have the ability to, because I'm in the process of custom fabricating this. What you'll notice from these is that I've got just a simple D-shaft from Tetrix running through. I've got it attached to a 42 sprocket. There's a hub on each side. And the other weird and wacky piece on here I had to go find was, this is an actual adapter plate that Andy Mark produces. You could also get from Studica if you wanted. And they actually are, they're actually plates that allow us to adapt. And I'm just going to make my wheel hub go away here. Let's grab the correct wheel hub. I believe it's that one. You can actually see that this will adapt an FRC pattern wheel hub to an FTC pattern wheel hub. They're both somewhat standard, which works great when you're combining parts. So now we've got one of those for the, I believe I called this one the front left, and I've got one for the front right. And if I got those backwards, I apologize. It's been a few years since I actually built a Mecanum. The other thing that I've built is one of my favorite parts in FRC, which is called a churro. Now, if you buy churros, you can buy these in massive lengths if you want to. What you actually get from this is, and I'm just going to go ahead and take a look here, you actually get your churro, which is this main piece here, and I've just actually finished this with a 1/4-20 bolt in each side. A 1/4-20 by 1/2 inch would do exactly what we're doing here. I'm actually going to go thread them for the sake of making them look proper. There and there. Let's do the threading. Your churros, when you get them, you can cut to size, and you can thread them together, and then just put the bolts in the end of them. This is what we're going to use to actually bolt the drive rail together and actually space it out. We're going to go a little bit away from what 7604 has done with this one. Now, there's that custom plate right there. Now, the key piece here is that we're looking at a mecanum, and we're going to put it in between two pieces of material. Again, probably plywood in this case, and we're going to have to put two motors in it. So I've assembled some part files that we're probably going to use. There you see you've got that churro we talked about. I'm actually going to use this 144mm angle aluminum to actually attach a lot of the pieces that are not a part of the drive rail. If you look at this in 7604, they've actually put this in at the top and bottom of their chassis. We're going to do the exact same thing. We also have some shaft collars. I'm actually not sure we're going to use those. I've got 3 different kinds of sprockets. I'm going to show you how to calculate the actual sprocket spacing itself. And I've also got an axle hub with a set screw. I got some bushings, which we've already used in the mecanum setup. We've got a tornado, which is my favorite kind of motor. We're actually going to drag one of those right into this drawing right now. We will get to using that at some point, because this is our actual drawing where we're going to space out some things. And then we're going to turn around and use our axles, our plates, and those churro tubes that we've already talked about. So let's get to it. Our material for this build is going to be 1/4-inch plywood or polycarbonate. Doesn't really matter for the sake of our design. And we're going to put a tornado on each of the mecanums. And I actually want to gear this thing to about 3-to-1. I want to use a 120-tooth gear on here and make these mecanums spin. You can use whatever gear ratio you want on here, or sprocket ratio you want on here. It really doesn't matter. It's one of the fun pieces of prototyping and testing. So let's start our drawing. Okay, I'm going to go ahead and I'm going to actually take this guy right here, and actually, you know what I'm going to do at this point? I'm actually going to delete this tornado, and I'm going to open the tornado in its own tab. Really what I need from the tornado is some standard measurements. I really don't need to put it on here necessarily, so I'm actually going to manually grab those measurements and actually put them on here. So what we do, we're going to start with our sketch just like we normally would. And I'm going to draw the front half of this drive rail. And to do that, I'm really simply just going to start from my base. I'm going to draw something, and I just realized I have a problem. I'm in millimeters. I'm actually going to be drawing this in inches because my number 25 chain has spacing at 0.25 inches. I know that my churros are all in imperial. Basically everything except my 6mm axles right now are all going to be done in imperial. So we're actually going to swap out our millimeters here in our document settings. And I can pop it open here and swap it to inches. Okay, I'm going to have to do some unit conversion on a couple things, but that's not the end of the world. We live in Canada after all, and that's kind of how things work. Okay, I know that I have 4-inch wheels. I know that my drive rails are going to be, they're probably going to be about the same height, so I'm going to make them 4 inches. We can change this later if we have to. And I know that the entire length of an FTC Robot is going to max out at 18 inches. So I'm actually going to make this piece 9 inches. Now, the reason for 9 is we're actually going to build the front half of this, and then we are going to add the back half of it later. So I'm going to trim out this side. All that I'm doing right now is I'm giving myself some space to work. I'm giving myself some space to actually figure out where this is. At this point, I'm going to start laying out some parts in the sketch. Now, what I'm going to do first is I'm going to grab a circle, and I'm going to draw the circle out so that it has a diameter of 4 inches. Use 4 inches because the mecanums are 4 inches. If I'm not sure, I can go over here, I can hop to one of my views, and I can simply grab an inspect function and grab something from one side to the other side of the mecanums. I got about 98 millimeters. I'm going to do some guesstimating on this one and say they're about 100 millimeters. That's about 4 inches. That's correct. We're going to roll with that. I'm going to drag this over so that I can see it. No, apparently not. Okay. I'm in my sketch. I've got a 4mm circle. Okay, I clicked finish sketch. I didn't really want to do that, so I'm going to go back to my sketch. And with this piece here, I'm going to select the entirety of the circle, and I'm going to go over to my sketch palette, and I'm actually going to change this to a construction line. Now, what a construction line does is it's going to make it so that this is not extrudable. If I try to extrude this, it's not going to take this wheel with us, because all we're using this wheel for is basically to measure how far away we want it to be from things. For this drawing, I kind of want to set it a little ways back, and I want to set it right about there. This isn't necessarily an exact perfect science on this one. I'm really just trying to make sure that this wheel is kind of in place to where it's going to be. Now, I know that this wheel is attached to a 40-tooth sprocket, and this is where things get a little bit weird. And I mean weird because the sprocket itself actually has it actually has a certain diameter and radius that you want to use for your calculation. And we're going to talk about the calculation here, which is weird. I'm breaking the cardinal rule of teaching, which is don't do math in front of students, but that's okay. We're going to try to do this live. I'm going to go back to my blurg part files, and yes, we named it after the character out of The Mandalorian. I thought that was quite cute. And I've created this earlier. It's just a sandbox view. So all I've got here, if you just want to take a look, is I've put these actual sprockets in place. I've got my 40 tooth, I've got my 80 tooth, I've got my 120 tooth. I believe that's what I got. Chain sprocket, doesn't list them in the part files. Could look those up. Anyways, regardless, what I've done with them is I've gone and done a sketch. And the sketch is really simple. I went in, and for each of the sprockets, I drew a link of roller chain. Now, number 25 roller chain is the one that comes with most kits. It's a really good kind of roller chain that you're going to use in a lot of your applications. It is standard. The reason it's number 25 is it's actually 0.25 inches in pitch. That means from the center to the center of each roller. These rollers are 0.13 inches in diameter. This gives me a pretty standard thing where I can actually test the spacing of my chain. Now, in this case, I've put the chain in here. And I know that chain being what it is, there's a little bit of slack to it. It isn't always tight. It kind of sits in those sprockets really effectively. But the reason I did this is to get a radius. And all I did to do this, I'm just going to grab I'm actually going to redraw this one. I'm going to go over to my new sprocket here, and I'm going to do exactly what I did to find the radius. I went up in my sketch, and I drew I could start with a circle if I want, okay, 0.13 because that's the standard of the chain. Take a line, I'm going to draw my line over, 0.25. I'm going to take another circle, I'm going to snap it to the end, and I'm going to go 0.13. There we go, we have a pretty good kind of estimation as to what a roller chain should be. And if I put it right here, this is about where it's going to sit. We are going to be off by a fraction on this one, and that's not the end of the world for the sake of this. What I'm going to do now is I am going to project the center of my sprocket on here. If I want to, I could actually project the outside of the sprocket as well. No problems with that. I'm then going to take a line, and I'm going to use the line. I could also use the measure tool here. And I'm going to just measure to the center of where that chain is going to sit. Okay. Once I get that measurement, I'm going to find out that I've got the thing at 0.16 inches. I'm just going to hop over to my 40 tooth over here and see what I got. Sorry, did I say 0.61? I'm going to go check that one more time. Emma, I'm just recording something right now. Can you come back in a second, please? Can you come back in a second, please? Press the home button, please. We had a Super Smash Bros. Problem. 0.616 inches over there. If I go back to this original one, I wrote them on the top, 0.615. So I'm, thousandth off there. I can deal with that kind of tolerance. I'm not working on aircraft after all. And that'll give us an idea of the radius that we need for putting this pitch in now, or this chain in. And that kind of is going to give us a little bit of guidance when we go back to our actual project here. So I know that I've got a circle now. And it is based around the idea that it is a diameter radius of 0.615. In this case, I'm going to double that up to 1.13, 1.23. Emma, can you hop upstairs, please? Thank you. This one, like the outside one, is going to become a construction line, and that's going to be our sprocket. Now, the next piece that we have to throw in here is we actually have to throw in the larger sprocket. So I'm going to actually draw it as well. I'm going to go back to my sandbox, wherever the heck my sandbox went. There we go. I'm going to use my I'm going to use my middle sprocket here, 0.945, and just so I get this right, 0.945. We're going to get 0.945 to 1.89. Okay, we're going to go back to our custom drive rails. We are going to draw this out at 1.89. Now, you'll notice that at this point, I'm not exactly putting this in an exact spot. If I want to move it now, I absolutely can, and I will have space on this particular piece of work. I'm actually going to space it away from the wheel, just so I guarantee there's no interference. Now, at this point, I've got some pretty good ideas of where things are going to go, but I want to actually make sure that those chain links mesh. Those pitches are at 0.25, but that means that the whole span around this entire double circle should be some multiple of 0.5, because I have to put two links together. It's how master links work. So what I'm going to do is I'm actually going to go calculate that as well. What I'm going to do is I'm going to draw a couple of lines on each of these. And where those lines are right now is actually not incredibly important, oddly, because we're going to put some constraints on them. Now, believe it or not, you actually have some constraints on this drawing already. And the constraints themselves are things that the drawing is going to try to keep constant. Okay, and I'll use an example here. I'm just going to make these construction lines right now. Right now, if I were to move this, if I were to try to move this wheel, you'll notice that the wheel goes with those lines and it goes with the inside circle. What you can see right here is two circles inside of each other. This is actually up here as a concentric constraint. That means that those two circles will always be concentric to one another. They'll always share a center point. Likewise, we can do some things to these lines. I'm going to draw a line from the middle of this circle over to the middle of this circle. I'm going to make it a construction line. And we're just going to use it as something. Sorry, there we go, construction line. We're going to use it as sign, kind of drawing the center point to the center point so we can play with it. We have a few different constraints here. Horizontal vertical is going to make a line always horizontal. If I do this to this line, it'll snap to the horizontal axis. I don't really want that right now. I'm going to send it back with the undo button. Coincident constraints means the end of two lines or 2 points are going to be basically constrained to each other. We're going to have a few of these. We actually, believe it or not, have a few of these. You can float over your various points. We actually have a few of these on the end of these circles already. That's a coincident constraint of where the line that runs between the two circles joins the middle of the circle, as well as both of those other circles running out to the outside. We have a few others, but the ones that we're going to work with right now are actually the perpendicular constraints. We're going to make this line and this line perpendicular. We're going to make this line and this line perpendicular. And what that's going to do for us is it's going to allow us to move this circle so that those lines stay perpendicular. Fun little trick of geometry for this one. Likewise, we're going to make this line and this line perpendicular, this line and this line perpendicular. And the rationale behind this is actually somewhat simple. This should allow me, I apparently have one of these that is vertical. Everyone sees right there, that symbol there means I have a vertical constraint, horizontal vertical. I really don't want that. I must have snapped this line to the vertical when I was drawing it. In this case, I'm just going to click the delete key and delete that constraint. That simply means that this drawing will be a little more free to move. It is less constrained. Yep, there we go. And you'll notice that I can move these around. Now this is important because this allows me to actually keep all of my geometry the same while still moving around. But why are we wasting all the time on this right now? There is a good reason for this. This is going to allow us to actually draw the circles of where the center of our holes go in this custom plate. That's going to allow us to actually put those holes exactly where they need to be. Now we said we wanted the whole thing to be some multiple of 0.5 inches. So what we're going to do is we're going to draw two more lines. We're going to draw a line along the top. We're going to draw a line along the bottom. These two lines are the most important ones because these lines here, as well as the outside half of these circles, are where the chain is actually going to spin. If we wanted to, we could actually trim off the front of these to better show this. I'm going to undo this and actually see where, there we go, we would actually see where the chain is going to move. I'm going to undo that. I really badly don't need those moving around more than they have to. There we go. Now, right now, if we took a calculation and we checked the actual measurement and we took the diameter of the circumference of this one and the circumference of this one, which, by the way, your measure command will calculate automatically. I did some math in the background here before we started, and we find out that the circumference of 1/2 of this, I just realized that my actual math value on this is actually wrong because I used a 120-tooth gear, not an 80-tooth gear. I guess we're doing live math again. So let's go back here and let's do some calculations on this. Clear this up. Okay, I know that I now have an 80-tooth gear, so I'm just going to update my math. Why not? Before I do that, I'm going to copy this so I have this for later reference. Let's go back to 80-tooth gear. And I know down here that my 80-tooth gear, when I measure it, let's go back to my measure menu. There we go. Inspect. I want to know only what the length of this is, 5.938. Let's go back to my notes. 5.938. 5.938, and the chain is only going to wrap around half of that circumference, so we're going to divide that by 2 to get our new one. Got our 5.938 divided by 2. We're going to get 2.969. 2.969. And that's going to then go around, and we're just going to add those together. We're going to add up that plus our 1.932, 4.901. Now, the only reason we're doing this is because we need to make sure when we space out our other lines here that the overall the overall amount, right now we're about 1/10 of an inch out, which actually would potentially cause some problems with our chain. You are inevitably going to end up loosening and tightening chain and finding out what your chain works with. But we're going to go ahead and actually make the circumference work here. So I got 4.901, so I'm just going to round off that thousandth and add 1/10 of an inch. So what we're going to do is we are going to go ahead, and we know mathematically that at this point, press escape a couple times, that this line here and this line here are going to be equal. They have to be mathematically because of all the perpendicular lines. I'm just going to snap this middle line to horizontal. I'm going to go back and make sure that my mecanum's going to have enough ground clearance so that it actually hits the floor. Again, if you're playing Rover Ruckus, you probably want this really close to the floor. If you're playing something like Skystone, you probably want it a little higher to get under the sky bridge. Depends on your game. At this point, we can actually take and we can measure one of these, and we can see that this right now is 3.603 inches. I'm going to actually apply a dimension to it right here. That's going to give me the wrong length, unfortunately. I need an aligned dimension. Let's see if I have aligned dimensions in Fusion. That's might actually be a thing for, it may not be. 3.58. I'm just going to check if that meshes with what I inspected earlier. 3.5, no, 3.63. All right, I guess we're going to have to get complicated for right now, and there may be an easier way to do this. If you figure one out, please let me know in the Discord chat, and we'll absolutely do that. I'm just going to straighten this one out and make sure we get all of our lengths the correct length. Okay, I'm going to grab this dimension, 3.66, oh, there's some numbers in there, and I'm just going to round this so that it is a multiple of 0.5, so I think we're going to go in this case 3.5, and then we determined that the circumference around those sprockets was 1/10 of an inch short of being a full inch. So in this case, we're going to add half of that, 0.05, to this to actually get our length that we want. I'm going to set that to 3.55 right there, and at this point I should be able to delete that constraint if I want to. Actually, I don't mind where this is going right now. I think I might leave this as is. Right now the motor is going to sit a little bit lower in this plate, and that's okay, there's nothing wrong with that. We're actually going to generate the holes for this right now, because this is just one of the plates. And how we're going to do that is we know that if we go back to our Mecanum drive, that I've actually used I believe this is an 8mm outside diameter cylinder here. Yeah, we're going to say 8mm for that one. 8mm outside diameter cylinder, so we know that when we go back to our plate, that the hole for this one is going to have to be 8mm. Okay, we're going to take this here. We're still in inches. This might be a point I have to swap out to swap this into millimeters temporarily. It's the cardinal sin when you're talking about drafting, is swapping between imperial and metric. We're going to make that not be a construction line. Now you notice that that's the first line in a while that we have not done as a construction line, because that's actually going to be a hole extruded in our plate. It's going to be something we're going to work with in this case. Now, down on the bottom here, we go back to our Torquedo. This is the motor that I'm going to use. So the same thing, I'm going to go ahead and I'm going to measure the outside of this. In this case, I get a radius of 6mm, a diameter of 12. Fantastic. So in this case, we're going to go here and we're just going to drop a diameter of 12mm on here while I'm still in millimeters. We're going to go ahead and we are going to take that out there. Now, this is going to give us our start. I'm going to do a couple of different extrusions here. Now, if you know your whole plan right off the bat, you can totally go ahead and actually finish all the holes that you would need. These are the two that I know about right now. So I'm actually going to finish this sketch. Now, what I get here, you can see I've got some construction lines showing the mecanum wheel, the sprocket, where the chain is going to go, and a lot of measurements. I'm going to go back into this sketch. I'm actually going to finish the other side because I now know that it's good. First thing I'm going to do, I'm going to drop another line in here, and you'll notice that I'm just throwing one in the middle. It really doesn't need to be that fancy. That's going to allow me to click on this circle, hold shift, click on this circle, click on the rest of my, what was a rectangle, now has 3 sides to it, and I'm going to use my mirror function. My mirror function automatically knows that I've selected 5 objects. I now go to the mirror line, and I pop this across to create the other half. Finish sketch. Now you notice that it closed that shape in. This is perfect, because what I really wanted to do with this was I wanted something that I could actually extrude. And at this point, I can actually extrude this out. Let's grab my extrusion proper. Here we go. One side. I'm going to set my distance to, oh, I'm back into millimeters. Again, cardinal sin, swapping between millimeters and inches. But when your suppliers are Canadian and American, sometimes you have to live in that world. Let's pull this out, 0.25 inches. I like to use 1/4-inch plywood when I do things on the laser. And I'm actually going to make this a brand new component. It doesn't need to be a body necessarily. I like my components. Now, what you'll notice here is that I've got holes already built into this for my torquedos. These are actually going to be bolted on here. And I'm not sure about the actual spacing here. I'm tending to wonder, what is the actual gap? 6.7 millimeters in this case, and 6.7 millimeters is just over 1/4 inch. So this is actually going to fit really effectively on this particular piece of work. So we're going to do a couple things now. The very first is we are going to go put some holes for those churros so that we can space things out. Now, we may end up just making 4 of these plates, putting one on each side of our drive wheels and calling it a day. But we first have to put holes to mount the torquedos onto this with. We also have to put some holes to put the churros in so the whole thing can hold its shape. So let's do those two things. And I'm going to do them in separate sketches. Right now, I'm going to put a brand new sketch on the outside here. And just to make sure I've got my spacing right, I'm going to throw a hole or a circle right here at 4 inches, just like we did before, as a construction line. This means I'm not going to run into my Mecanum wheels. And I'm going to be really lazy about this because laziness is a really good thing when you're working with repeatable steps. I'm actually going to set a new construction line inside this. Actually, you know what? We could use an offset from the rectangle, or we could get really fancy. We could actually create an offset from, here's our offset button, from the Mecanum wheel itself. Now, I know that my churros, because I made them and because I chose the ones I wanted, are a 1/2 inch in diameter. So as long as I'm greater than a 1/2 inch out here, I'm probably set. I'm actually probably going to set the center of them at negative 0.5. Oh, sorry, that should be positive 0.5, and actually put it out here. Now, this is a point where kind of at an art versus science question. We're just going to take a circle, and I'm just going to draw my circle down here. These are the circles we're going to use to drill the actual holes or bore the holes for the churros in them. I'm going to go 0.25 because the churro uses a 1/4 20, 0.25, 20 threads per inch bolt on it. And I'm actually going to do what's called a coincident constraint on this. I'm going to click the middle of this, and I'm going to click the edge of this circle. Oop, I have to escape first. Coincident constraint, center of this circle snaps to there. You'll notice that now that I've put that coincident constraint there, if I want to move this circle, I can, and it'll always snap to that guiding construction line circle. I'm going to put one down here. Now the purpose behind these churros is really just going to be to hold the shape of this whole rail. And in some games they can be used, such as Rover Ruckus, they could be used to keep various game pieces out of your frame, which can be really annoying depending on your wheel setup. I'm going to have some fun with this one though, because why not? We're here. What I'm going to do is I'm actually going to go down and use a circular pattern to really quickly make a whole bunch of holes. Okay, I'm going to click on this one here, and I get some options with my circular pattern tool. Apologies. I actually have to choose my center point, so I'm just going to click the center of the circle. Easy enough. And then I'm going to actually make this an angle. Now you'll notice it's going around that way right now. I kind of want to go the other way. There we go. It's going to give us negative. And let's say that I want to put 4 of these churros in around my wheel to make sure it's nice and stable and it'll never go anywhere. Let's say for the sake of argument I want to move this to 180 degrees. Sorry, that should be a negative 180 degrees because it's going clockwise in this case. And that's going to give me those holes right about there. Now you see that gave me the 4 holes. That's exactly what I was looking for. And in this case, I could very easily go ahead and draw them on the other side. How do you ask? Well, we know that this plate has a center point, so we can draw a construction line there. Then we can simply go ahead and click all of the holes that were created by this. I'm going to make sure I actually get the actual outlines of them this time, because when I practiced this earlier, I did not. I believe I don't have that one. That's going to allow us to do another mirror command. Select our mirror line. I actually have 6 things selected. Let's make sure. I got 4 holes. Life is good. Now from here, I'm going to turn around and I'm going to finish my sketch. It's going to allow me to get to a point where if I want to do a negative extrusion of these, I could actually go ahead and extrude these. I don't actually like where that top one is sitting. I think it's a little too close to the top, but for now, we're going to leave it as is and go from there. And actually, no, that's going to bother me if we leave it. From here, we're going to actually extrude this negative 0.25 inches, and it's going to cut those holes in the chassis. Now we know what those are for. If I go back to my sketch, this is where this gets really neat. I realized I really didn't like where this middle hole was here. So I'm actually going to go back and I'm going to go modify a few things here. Specifically, I'm going to go modify where these guys are sitting. I can actually move them all around. I'm actually going to simply rotate this one so it's a little closer to the middle. You'll notice when I do that, I actually press enter, it's actually going to move. If we zoom out, we can see it's actually moved the other side as well because they're based on each other. They're based on a mirror across this line, so we could move massive pieces. And when we click Finish Sketch, those holes are all going to move. They're actually going to relocate themselves based on where we did that. Now, this isn't anything to write home about yet. It really isn't, but we're getting there. So the next thing we're going to do is we are going to throw in a Torquedo motor. Because at this point we have enough of a plate that we could actually put the holes in it. So I'm going to go back to my part files for the blurg, and I'm going to simply drag in a Torquedo motor. Torquedos are fun. They're a bit of a unique motor in some senses in that they have their drive shaft off center, and it is a blessing and a curse in some ways. What we're going to do is we're going to grab that side of that Torquedo, we're going to grab that side of the Torquedo, and I'm going to actually put a revolute joint on it because I don't quite know which way I want it to sit right now. I'm going to go to my visibility, I'm going to make my plate move, and I actually like the orientation that Torquedo is sitting in right now, so I'm going to leave that there. What I'm going to do is I'm going to start a new sketch on this side of the drive plate, and then I'm going to actually make the drive plate go away. And the reason I'm going to do that is because I actually want this Torquedo to be a key piece of this. I actually want to use the holes that are already here. So I'm going to go into my Create tab and I'm going to actually project the outside of this Torquedo. Now the purpose behind that is relatively simple. What I really want are these 6 holes here. Those should be number 6 bolt holes. They should actually work with the bolts you have in your Tetrix kit. Now you'll notice that when I float around here, I'm just going to make the Torquedo go away so it shows a little better. It's actually pulled that onto the near side of this particular plate. And that's perfect, because what I really want to do right now is I want to actually go ahead and I want to extrude those things out. Before I do that, I'm actually going to do what I did before, and I'm going to go ahead and copy them across to the other side, just so everything's nice and symmetrical, so it makes us happy. Press Escape, draw a mirror line. Now, I will warn you, you could have done all of these steps that we did in a single sketch if you wanted to. I've been kind of compartmentalizing them because it makes it easier to learn, but if you want to do this in one big sketch, you can do that, as long as you keep track of your constraints. So realize that I've selected a few center points instead of the circles themselves. It doesn't matter if I grab the center points as well. I'm going to mirror these again right across center. Okay, you're going to notice that they are going to go across exactly like the other ones. Finish my sketch. I'm going to zoom this so I can see everything, and I'm simply going to extrude out the donut holes as they were for all of these bolts. Now, you may not have bolts long enough in terms of quarter-inch bolts or quarter-inch long bolts to actually dive into a Torquedo, but this is again where custom fabrication comes in. If you want to go down to, Bolt Supply House, anywhere else that does kind of weird and wacky bolts, even Home Depot and those places will often have these, you'll actually be able to get longer bolts and actually just bolt your Torquedos. I'm going to make my Torquedo come back. There it is. You're actually able to bolt it straight onto your drive rail. There you go. Not bad. Now, from here, I'm going to actually start adding some parts to make sure everything fits. So I'm going to just do the front half of this one, just for the sake of time, but I'm going to throw a couple of churros into the front just to make sure they fit. There's the churro I made before, again, with the bolts already built in, and I'm just going to have some fun with some assembling of this to throw the joint in. And this one, instead of being revolute, I'm going to make rigid. You'll notice all my parts are moving all over the place. I don't exactly love that, so I'm going to go ahead and make this component. I'm going to rename it. Double click, we're going to call this inner drive rail plate. Good names, help you navigate your CAD files. They are always worthwhile. I'm going to take my churro, I'm going to copy it and paste it. I'm going to grab a new one here. And we're going to do the same thing. I'm just going to join this thing into place so that we get another churro there. Now, in an ideal world, I would do this with all my churros, but you can kind of see where I'm going with this. Once we get 2 drive rails on here, we're going to be able to put our wheels in. I'm going to actually do that right now. So let's assume that this is the left-hand side of our robot. Could be the right hand, depending on which way we're looking at. Actually, let's go to home. Yep, we're going to call this the left-hand side for right now. So I'm actually going to go into my part files, and I'm going to go to Blurg, and I'm going to grab a front left drive wheel, mecanum wheel. I'm going to bring this over here, and I'm just going to rotate it around, close enough. And the piece that I designed this with whatever in mind is actually, we put this 8mm hole here. This 8mm hole is going to let us actually click here. I'm going to go and actually make this a revolute joint, because why not? We may as well have our mecanum spin. And it's actually where this second component is going to sit. That's super disconcerting, but it actually accomplishes what we need it to do. Go back home. We're going to see that we now have a inner drive wheel. Should be grounded so it can't move. And now that should give us a mecanum that spins. Now you'll notice that I haven't taken any chances with this. I've got my actual churros right there, and they've actually been cut to size. There's, again, a little bit of custom fabrication going on here that's going to allow us to put this actual sprocket in here. I've left a few millimeters of space around here. You'll notice that everything's really tight right now. You're going to need a few spacers and a little bit of space to move some stuff around. That's usually done in the prototyping phase. That being said, from here, we know that we've got kind of everything we need to get this going. I'm going to throw the other sprocket in here. We made this an 80-tooth sprocket, I believe. And I'm just going to drag this guy over here. Clearly, one piece of this has been put in at a bit of an angle, and that's okay because we're joining everything together. Might be a little bit weird when we do our drawing file. That being said, I'm going to cheat a little and put my axle hub here, even though that should be a motor hub. And from there, we're going to go ahead and put in this next piece. We're going to do a join of this onto the inside of this. And again, in reality, if you did this on your FTC Robot, this would be done with 4 bolts. I'm using a rigid constraint just to show how this works. And from there, I'm actually going to take a look at where I've put my spacer, and I'm not entirely happy with that. I'm actually going to undo what I just did, and I'm going to constrain this a little bit differently. I'm actually going to constrain the inside of that hub to the outside of that hub. Is that how I've done it there? Not quite, but it will line up regardless. Okay, there we go. And then from there, we're going to turn around and just put a joint on this cylinder and this cylinder right here. Again, if I feel so inclined, I can make this a revolute joint so that they can spin. And I know that these pieces are joined in such a way that I probably want to have a little bit of space there. And there we go. Now I've got a sprocket that spins. If I wanted to, I could motion link these things together like we talked about last week and put a motion link on what I believe, to the best of my knowledge, is a there to there. Get a little bit better angle on this. And then I believe these are 2 to 1. I'm not 100% sure. I'd have to check the data sheets on them, but I believe that that is going to give us the correct movement pattern. And so we now know that if we spin this Torquedo, we're going to get movement here. Now, I've made this plate, and on a laser, this is relatively easy. On a CNC mill, this is relatively easy. If you're using your hand drill, this is kind of hard to get right. You have to be really accurate with your actual hole spacing on this. But the cool piece with this is once you've built the initial piece of this, you can actually put the other side of this on as well. And what I'm going to do is I'm actually going to go ahead and take this drive rail, I'm going to right click it, and I'm actually going to copy it as a component. Okay? And I'm then going to go ahead and paste a brand new version of it, and I'm going to drag it across. Now, I would actually join this properly if I were doing this full bore as a part of our FTC Robot. Just going to make our joints go away right now by turning them off so we can see kind of where everything is. Oh, still have some joints showing up. Why is that? Oh, because they're joints for other pieces. That's okay. You can actually see if we zoom in here that we've actually got this lined up. We actually have the bushing in place in the outside of this. It shows me that my churros may have actually been slightly too long, and that's okay. Churros are cuttable, grindable. It's kind of why we CAD things. And From here, we can actually turn around and find ourselves putting the rest of this together. We could actually say that our front right assembly, it's actually the other wheel that goes into a mecanum, can go in. And I'm actually going to assemble this piece as well, just to show you what we're getting at with this idea of the drive rail. And this is a really sturdy way of doing things. Now, every piece of this from here on in is simply adding new extrusions to mount things on. If we want to go to our part files and add some of our L brackets, I believe I have some of those here, axles, there we go, our 144 millimeter angle axle, we can absolutely do that. And it would allow us to start building things that look kind of like 7604's drive rail, where we actually have something to attach to the top, or the bottom as it were. I know they've done this as well here. Oh no, they didn't do it at the bottom. They used channel. You could do it at the bottom as well if you wanted to. From there, we would just simply join this in, and I'm just going to do this for the sake of looking at something that will, I think, be quite pretty at the end of all this. Not the least of which since I've put some time into it. And we're going to mount this onto exactly where we designed it, right there. Nice revolute axis. And let's get this thing in place. There we go. We've got some moving mecanums. We've got a place for our torquenados, and we have a couple pieces of dry plate. Now, a good idea, not a bad idea to actually work with the outside plate, maybe make it different than the inside plate. Maybe we decide we want to actually edit some of these pieces or put them as sub pieces in our actual folder. There's nothing wrong with that. But this is kind of how you design a custom fabricated drive base as it was, so that you could actually have something really sturdy, really relatively reusable, and something where, unlike a kit part chassis, you could actually take and I realize what I've done here. I actually have to go back for a moment. You actually could take and change the sprocket ratio on it, change how fast this is moving. There's a few things you could do here. I just realized that I didn't constrain my torquenado correctly, so I'm actually gonna fix that right now. First thing I'm gonna do is I'm gonna grab a joint here of the edge of the torquenado. I'm gonna grab that one right there, and then I'm gonna go back, and this time I'm gonna make the inner plate show up again, and I'm gonna find the matching space for it, which I believe, if I zoom in, will be that one right there. I'm gonna joint them together, and I'm gonna make it so that it's just a rigid joint, so that that torquenado can't go anywhere anymore. There we go, there we go. Now we're moving the way we're supposed to. All of that is a good way of thinking about building that custom drivetrain. And again, it's a good off-season project because you can be pretty certain that there's only a couple of different drive bases that'll be useful in an FTC game. Typically we have mecanums, and typically we have something for an uneven ground game where something like a, six-wheel drive, Omni-type drive, or those sort of things actually work really effectively. Anyways, take a look at this, enjoy the CAD, and I'll throw the rest of this design together so that you can see the full thing in action. But try it out, play with some custom parts, and let me know what you find about it in the Discord. Cheers.